Hi, I wanted to do a couple examples. So we've got absolute value equations in this section, and we've got some rational exponents. So I'm going to start with the absolute value. So these are problems similar to what you'll see on your homework. So we have the absolute value of 2x minus 3 equals 15. Whenever you're solving an absolute value equation, you're going to set up two problems. Your first problem is going to be exactly what's written without the absolute value. So we're going to have 2x minus 3 equals 15. That's one equation that you're going to solve. The other one is going to be what you have in the absolute value, but you're going to switch your sign. So you're going to change that to a negative 15. So what you're going to want to do is solve both of these individually. So we're going to add 3 to both sides. We would have 2x equals 18. So x equals 9. On the next one, we'd have 2x equals a negative 12. And x would be a negative 6. So we would have two different solutions for that absolute value. Now, it's always good to check our solutions or check your answers. So checking answers, just plugging it back in. So if you think of plugging 9 in, you have 9 times 2, which is going to give me an 18 minus 3. The absolute value of 18 minus 3 does give me 15, so that one does work. Then check our negative 6. Negative 6 times 2 gives me a negative 12. Negative 12 minus 3 is a negative 15, but the absolute value of that is also 15. So in this case, both solutions work. The next problem looks a little bit different because we're dealing with a quadratic and an absolute value, but your steps are really going to be exactly the same. So you're going to set up two equations. One, again, exactly what's written without the absolute value. The other one, what's in the absolute value, and then you switch your signs. But when I switch signs, I have to switch the sign on every single piece. Now, really, I'm solving a quadratic equation. So I'm going to subtract x on both of these. So I'd have 0 equals x squared minus 15. Add the 15 to the other side, we have x squared equals 15. So x would equal plus or minus the square root of 15. On the other one, again, we can do the same thing. So I'm going to subtract x. So I'd have negative x squared minus 2x plus 15. I don't necessarily like my quadratic term to be negative, so I'm going to divide everything by a negative to switch my signs. So I'm going to have x squared plus 2x minus 15. Now, when I look at this, I can see that I can factor. So I would have x plus 5 and then x minus 3. When I set each piece equal to 0, I get x equals a negative 5 and x equals a 3. Now, in this case, we really have to be careful. We do have to check our solutions. So if we plug in, let's start with positive square root of 15. So in that case, we would have the absolute value of the square root of 15, which is going to give me the square root of 15. On the other side, we'd have square root of 15 squared plus the square root of 15 minus 15. In this case, square root of 15 squared is 15. 15 and a negative 15 will cancel, and then that part works. So one solution that we do have that works is the square root of 15. We have to do the same with the negative square root of 15. Absolute value of negative square root of 15, again, is square root of 15. I would have negative square root of 15 squared minus the square root of 15, and then minus 15. Again, negative square root of 15 squared and the 15 will cancel, but square root of 15 is not equal to negative 15. So the negative one will not work, and that's called an extraneous solution. We also have to test our other two solutions. So we have our negative 5. So absolute value of negative 5 gives me a positive 5. Then we would have negative 5 squared minus 5 minus 15. Negative 5 squared is 25. 25 minus 20 is 5, so that solution does work. So x equals negative 5 does work. Trying the 3, we would have 3 equals 3 squared minus 3 minus 15. 9 minus 3 gives me a negative, 9 minus 3 gives me, oops, sorry, it should be plus 3. So 9 plus 3 is 12. 12 minus 15 is a -3. -3 is not equal to +3, so that solution doesn't work. So in this case, we really only have 2 answers that would work. So you must, again, make sure that you're checking your solutions. The last problem that I do want to show you is one that looks like this with rational exponents. Now, one thing to note is when our power on our x's, if one is double the other, then it's what we call quadratic form. So quadratic form means you can kind of solve it like a quadratic equation. So we're going to move everything to one side. And we're going to solve it using the quadratic formula. But normally with the quadratic formula, we say x equals. And that's because our middle term is just an x. In this case, our middle term is not just an x, it's an x to the 1/3. So we'd say x to the 1/3 equals. Now, if you remember your quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So plug in your values. We have -6 plus or minus the square root of 6 squared minus 4 times 3 times 2.1 all over 2a, so 2 times 3. Then we need to plug this in our calculator. So when we do this, we're going to take 6 squared minus 4 times 3 times 2.1. So when you do that, I'm going to go ahead and do it here on my calculator. So -6 plus the square root of 6 squared minus 4 times 3 times 2.1. So I'm doing just the positive one for right now. I'm going to get that answer. I'm going to divide it by 6. So I get a solution that says x to the 1/3 would equal a -0.452277, and it kind of goes on forever. Now I have to get my other solution. I'm going to do kind of the same thing, except for instead of the positive, I'm going to subtract. When I subtract that and I divide by my 6, I get something that says x to the 1/3 is -1.57 or 547722. Now, your last step that you have to do here is raise both of them to the 3rd power. And then that will give you your x values. So if you take your -1.544 and we raise that to the 3rd power, we get a -3.71 if we're going to 2 decimal places. Actually, it says 3 decimal places. So if we go a little farther, we would say -3.707. And if we do the other one the same way, so we're going to take our -0.452277 and we're going to raise it to the 3rd power. That's going to give me a -0.093. And those would be our 2 solutions. So hopefully that will help you get through this next assignment. If you have any questions, please make sure that you email me. Have a good night.